Okay, we're going to talk about IP addressing lab. So IP addresses are used to identify a computer, just like social security number is used to identify a person, or VIN number is used to identify a car. So IP addresses identify a computer. So IP address is basically four numbers. You will see something like this. Okay, you must have seen something like this. Okay, so these are IP addresses. So IP address is basically four numbers that are separated by dots. So 192 is the first number, 168 second, one is the third, and one is the fourth. So this is called dotted decimal notation. So this is dotted decimal notation. All right. So four numbers separated by dot, and the condition is each number is basically greater than or equal to 0 and less than or equal to 255. Okay, so um, 0.0.0.0 is the smallest IP address, and 255.255.255 would be the largest IP address. Okay, so if somebody says, so if I say is 10.1.1.250, is this a valid IP address? So this one 10.1.1.256 is not a valid IP address, because the four numbers, all four numbers should be between 0 and 255. So anything that contains 256 is not a valid IP address. All right. So IP address is basically a IP address is if you write in binary, IP address is a 32-bit number. Okay. So IP address is a 32-bit number. So in computer science, everything is in binary, ones and zeros. So in real life, we use decimal number system. So in decimal, we have 9 symbols, 0 to 9, and we write numbers using a decimal number system. In binary, the only two symbols, 0 and 1. So computers only understand um, 0 and 1. So low voltage and high voltage, because electricity is used to store data as well as send data across the wire. So 0 is low voltage and 1 is high voltage. So 0 and 1s is all computers understand. So we use a binary number system uh, for computers as well as for networking. So IP address is basically a 32-bit binary number. Okay, so if I write this, let's say 1 2 3 4 5 6 7 8. Okay, so this looks like a valid IP address. So this is a 32-bit number. So 8 bits, I've made groups of 8. So these are called 4 octets. Okay, so these are 4 octets. So a group of 8 bits is basically an octet. All right, right, of 4 bytes. So we should be able to convert binary to decimal, decimal to binary. So IP address written in this dotted decimal notation 192.168.1.1 could be converted to binary, something similar to this ones and zeros 32-bit number that you see here. So that's what we're going to look at. So first of all, we're going to see how to convert decimal number to binary and binary to decimal. So I have provided you with this table. So you'll see this table has 8 numbers. We start 8 boxes. Okay. So we start with 1, and then the next number you get is basically the previous number multiplied by 2. So 1 multiplied by 2 is 2, 2 multiplied by 2 is 4, 4 multiplied by 2 is 8, 8 multiplied by 2 is 16, 16 multiplied by 2 is 32, and then 32 multiplied by 2 is 64, 64 multiplied by 2 is 128. So these are basically powers of 2. Okay, so 1 is basically 2 to the power 0. All right, so I'm going to use this notation. 2 is basically 2 to the power 1, 4 is basically 2 to the power 2, and 8 is basically 2 to the power 3. All right, so these are basically powers of 2, these numbers. All right, so 128 is basically 2 to the power 7. So I have provided you with this box and these numbers, and using this table you can convert decimal to binary, binary to decimal very easily. So first of all, let's say you want to convert, let's say you want to convert a binary number to it. So let's say you're given this number. All right, so let's say you're given this 8-bit binary number and you want to convert to decimal. How would I do it? So I'll add all the numbers if there is one below it. So I'll add 128, 64, 32. Then I will add 2 and 1. So if you see 1 below the number, then you add the numbers above it. So I see 1 below 128, I see 1 below 64, 32, and I see 1 below 2 and 1. So those are the numbers I add. So if I add those numbers, what I'm going to get? So 128 plus 64, 192, plus 32, 224, plus 3. So that's going to be 227. So this is basically 227 in decimal. All right. Okay, so that's how you do it. So let's say you're given this now. Let's say that's the binary number. So in binary it's 00110010. What would it be in decimal? So all you do is like add the numbers in the box if there is one below it. So I'm going to add 32, 16, 2, no 1 actually, 32, 16 and 2. Okay, that would be 50. So this number, so 50 is basically 00110010 in binary. All right, so binary to decimal is very simple. Okay, so all you have to do is simple addition and you'll be able to do it. How do I convert decimal to binary? All right, so let's say I'm given some decimal number. I want to find what is the binary equivalent of that number. All right, so let's say I'm given 210. So how would I find how to write 210 in binary? All right, so first of all, what I'm going to do is like start from the left side of the table, see if I need 128. So basically I need to find which of these numbers add to 210. Okay, so I have to start picking numbers so that they will add, so their addition would be 210. All right, so which numbers add to 210? So I think for 210, I do need 128. Okay, so if I pick 128, how much I'm left with? So if I pick 128, I'm left with 82. All right, so I pick 128, so I'm going to put 1 below it. All right, so for 128, I do need 64. I'm going to pick 64. So if I pick 64, I'm left with 18. So for 18, I need only 18, so I don't need 32. So I'm going to put 0 below it. Okay. So for 18, I'm going to pick 16. So if I pick 16, I'm left with 2. I need only 2, so I don't need 8. I don't need 4. I need 2, so I take 2. And then I need 0, so 0 I don't need. For 0 I don't need 1, so I put 0 under it. Okay, so the numbers I need for 210 are basically 128. I need 64. I need 16. And I need 2. So these four numbers, they add up to 210. So 128 plus 64 is 192. Plus 16 is 208, and 2 is 210. Okay, so 210 in decimal is basically 11010010 in binary. All right. Okay, so that's how you convert decimal to binary. You start picking numbers from the left side. So you see if you need 128, and then find out how much you're left with, and then you decide if you need 64, and then you find out how much you're left with, and then you go on like that. And if you pick these numbers, you write 1 below. If you don't pick, you write 0 below them. Okay, and that's how you get the answer. So you want to convert all these decimal numbers to binary. So 99 is basically 0, 1, 1, 0, 0, 0, 1, 1, because 99 is basically 64 and 32, 96 and 2 and 1. So for 99 you need 64, 32, 2 and 1. That adds up to 99. So you're going to convert all these numbers to binary. All right, and we are only dealing with 8-bit numbers because IP address is a 32 number, and we divide that 32-bit number into 4 octets. So 8-bit numbers is all we need to worry about. So IP addresses are basically, the smallest IP address is 0000, and largest IP address is basically 255, 255, 255, 255. So we have how many? 2 to the power 32 IP addresses. 2 to the power 32 IP addresses, which is basically more than 4 billion IP addresses. Okay, so the smallest is 000, and largest is 255, 255, 255, 255. Okay, so IP addresses are divided into 5 classes. So class A, B, C, D, and E. So if your IP address starts with if your IP address starts with if the first octet is from 0 to 127, okay, then it is class A. Okay, so you can tell which class IP address belongs to just by looking at the first octet. Okay, so if you look at 192.168.1.1, then 192 is the first octet. So you can look at the first octet of the IP address and you can tell which class it belongs to. So the first octet is from 0 to 127, it is class A. If it is 128 to 191, it is class B. If the first octet is from 192 to 223, it is going to be class C. If it is 224 to 239, it is class D, and if it is 240 to 255, then it is class E. Okay, so you can see starting addresses for class A is going to be 0000 to 127.255 to 55 to 55. Okay, so for class B it's going to be 128.000 to 191 255 to 55 to 55. Okay, so you can see this IP address belongs to class C because the first octet is 192. So first octet is 192. Okay, so it belongs here. That belongs to class C. So in real life, you will see, if you look at the IP address of computer, you will see class A or B or C IP addresses. Okay. Class D is used for special purpose called multicast communication. So we're going to talk about that later. And class E is reserved by government and military. All right. So, and there is something called subnet mask associated with each class. So subnet mask is is associated with class A, B, and C. IP addresses D and E are not used with subnet mask. So the default subnet mask for class A is 255.000. Default subnet mask for class B is 255.255.0.0. Default subnet mask for class C is 222.55.0. Okay. So subnet mask is a little complicated concept, and subnet mask basically is used to identify which part of the IP address identifies the network and which part of the IP address identifies the computer. Okay, just like your name, part of your name identifies your family, which is last name, and part of your name identifies you, which is your first name. Okay, similarly IP address has two parts. So here 192.168.1, this one identifies the network, and one identifies the computer. Okay, this last octet identifies the computer. Okay, so this is because first 24 bits of class C IP address identifies the network address, and last 8 identifies the host address. Okay, and subnet mask tells you that. So 222.55. So if you write down 222.55 in binary, you're going to get so this is 255. Okay, and so this is 255 222.55.0 in binary as a 32-bit number. Okay, so so that's basically the subnet mask. Okay, and this is subnet mask 255.0 in binary. Okay, so subnet mask tells you which bits are network bits, which bits are host bits. So basically first 24 bits of the IP address are network bits. So ones are network bits and zeros are the host bits. So first 24 bits are the network bits. Okay, and last 8 bits are the host bits. Okay, so if I look at this IP address, first 24 bits identify the network part and last 8 bits identify the host part. Okay, so if I look at that IP address, 192.168.1 is the network part and 1 is the host part. Okay, similar to your name. All right, so this identifies my family and this identifies me. All right, so rest of the activity, you're going to convert the IP addresses to binary format, 24-bit number. You're going to identify which class they belongs to. All right, and you're going to identify the default subnet mask for the class. So 222, you're going to convert to binary. So the first octet is 222. So first octet belongs to 222. So it belongs to class C. Okay, so it belongs here. So the class is going to be C. All right, and the default subnet mask for class C is always 222.55.0. Okay, so that's what you're going to write it down. So what that means is, like, if you have class C IP address, first 24 bits identify the network to which the class belongs to, and last 8 identifies the host. All right, and then you're going to convert this to binary format. So you're going to do this for this whole table. All right, and there's another table that converts decimal to binary. That's all for this lab.